Have you ever stopped to think about all the different computers out there? I mean, they're everywhere, from the one that's probably in your pocket right now to these massive, room-sized machines that literally power our world. So what actually makes them all computers? Well, let's break it down and figure out how we classify these incredible devices.
Yep, you're using one right at this very moment. It doesn't matter if it's a smartphone, a tablet, or a good old-fashioned laptop. You are interacting with a machine that falls under this huge, powerful umbrella category we just call a computer.
Okay, so with this insane variety of machines, how do we even begin to make sense of it all? Let's dive in. We're going to build a kind of map to help us navigate this whole world of computers.
To get our bearings, we're going to start with the type of computer we all know and love, the one that's probably sitting on your desk or maybe even in your lap right now. So meet the hero of our modern story, the microcomputer. You probably just call it a PC. You know, when these machines exploded onto the scene back in the 70s and 80s, they didn't just change technology, they literally changed society itself. So what was their secret sauce? What made them so revolutionary? Well, it was a pretty simple formula, really. They were made for just one person, they were compact, they were actually affordable for regular people, and, this is the big one, they were incredibly versatile. That versatility is the key. It's what made them the absolute backbone of everything from education to e-commerce. But your PC is just the tip of the iceberg. One of the clearest ways we can classify computers is by their sheer size and power. So let's start scaling things up a bit. Okay, next up on the ladder is the mini computer. And don't let that name fool you, there's nothing mini about its power. Think of these as the workhorses for a medium-sized business. They're powerful enough to support up to, say, 250 users at once, managing things like company-wide databases or processing a ton of transactions.
And now we are getting into the big leagues. This is a mainframe. These things are huge, super expensive machines built for thousands of people to use at the exact same time. You know, think about your bank. Every single time you use an ATM, that transaction is almost certainly being processed by a mainframe, handling this massive, constant flow of data without even breaking a sweat.
So how do you even measure that kind of raw power? Well, we use a metric called MIPS, which stands for millions of instructions per second. It's a staggering number that just tries to quantify how much work these processing beasts can get done every single moment. All right, at the very, very top of the mountain, the absolute pinnacle of computing power, we find the supercomputer. These are hyper-specialized machines, really, designed for the most complex and intense tasks you can possibly imagine. The name of the game here is speed. I mean, we are talking about billions of calculations every single second. This is the kind of power you need to do things like simulate crazy complex weather patterns or model how molecules interact for drug discovery. They are truly in a class of their own. So let's just recap this whole size thing real quick. You've got microcomputers for you and me. You've got mini computers for teams and small companies. You've got mainframes for huge organizations. And then you have supercomputers for tackling the world's biggest scientific puzzles. Each one is a specific tool built for a very different size of problem. Okay, so size is one way to look at it, but there's another, much more fundamental way to classify computers. Not by how big they are, but by the very nature of the data they process. It's all about how they think. First up, we have the analog computer. Now, this might seem a little old school, but it's a totally fascinating concept. Instead of using numbers, it uses continuous physical things, like, say, the movement of gears or the flow of water, to actually compute. It's a machine that works directly with the measurable, real world. And right here, this is the core difference. Analog computers process continuous signals. Think of it like a smooth, unbroken wave. But digital computers, the ones we're all familiar with, they break everything down into these tiny, discrete, separate signals, the famous binary code of zeros and ones. So what happens when you combine the two? Well, you get a hybrid computer. A great example is a patient monitor in a hospital. It uses analog sensors to measure a continuous signal, like a heartbeat, but then it converts that into digital data for super precise analysis and display. It's literally the best of both worlds. All right, so we've covered size and we've covered data type. Let's move on to our final way of classifying these things, a computer's intended purpose. Is it a jack of all trades, or is it a master of one? This is a really important distinction. On one side, you've got your general purpose computers, like your laptop. They're total chameleons. They can do a huge range of things just by running different software. But on the other side, you have special purpose computers, which are designed to do one specific job and do it incredibly well. A perfect example is an ATM. And honestly, you'd be surprised how often you run into these specialized machines. The little embedded system that controls your car's engine, an MRI machine at a hospital, even the computer inside your microwave. They are all special purpose computers, each one optimized for a single critical function. Okay, so we've looked at computers through 3 completely different lenses: their physical size, the way they process data, and their ultimate purpose. Now, let's put all those pieces together and see the full map. And here it is. This is our complete map. We can understand pretty much any computer by looking at it through these 3 distinct categories: its size, its data type, and its purpose. So let's test this map on something we all know, your laptop. Okay, by size, it's a microcomputer. By data type, it's a digital computer crunching ones and zeros. And by purpose, it's a general purpose machine, ready for any software you throw at it. See, it fits perfectly into our framework. So there you have it. From those room-sized giants all the way down to the phone in your hand, every computer can be understood through these 3 key lenses: its size, the way it handles data, and its purpose. But you know, with new technology like quantum computing just around the corner, it kind of makes you wonder, what's the next category on our map going to be?